Hello there, welcome to question 10 of our physics exam preparation series. In this question, we'll be looking at photoelectric effect, and we are now going to start with the first two questions. Have a look. Alright, so what can we conclude about the nature of light by studying the photoelectric effect? One conclusion we can talk about is this one, where light is being quantized, or because of a collection of particles, there is an amount or a quantization of light that can take place to help us describe this process or this phenomenon called, the photoelectric effect. Okay, good. So now we are going to 10.2, where we're asked to define the work function, which is the minimum energy that can eject electrons from a metallic surface. All right. So that takes care of the first two questions. Let us go to the next one. Have a look. Okay, so 10.3, we're asked to calculate the maximum kinetic energy of an electron ejected from the metallic surface. There's an equation that can help us there that relates the Planck's constant with the frequency and says it's equal to the work function plus the maximum kinetic energy. So the substitution takes place here, and we arrive at 5.31 times 10 to the power negative 20 joules of the maximum kinetic energy there. Right, so that was straightforward. Let us go to the next question. Right, so for 10.4, we need to look at what is given. We've got the current, we've got the time it takes, and we are looking for the minimum number of photons that strike the cathode. Now, what can we do with these two quantities? We can calculate the charge, right, or the amount of charge, and it's 0.012 times 10, giving us 0.12 coulombs as the magnitude of charge. We take it to this equation that helps us to talk about the quantization of charge, which is the number of photons or electrons in this case is equal to the charge divided by the charge per electron, and we get 7.5 times 10 to the power 17 photons in this case. So yeah, this takes care of 10.4. Now, so 10.5, we need to talk about what will happen if we increase the intensity of the incident light in relation to the reading on the ammeter. The reading will definitely increase. Why? Because more photons will strike the metal surface at a faster rate or at a higher rate, and therefore will result in a greater amount of current being registered on the ammeter itself. So yes, guys, this takes care of our physics exam preparation series. Thank you for watching all the videos under this section, and if you've not watched all the videos, I invite you to go all the way to question 1 and come back to question 10, gradually going through the entire paper. Keep well, keep working, and continue achieving those excellent results. Thank you so much. See you next time. Sharp, sharp.